Hello everyone, welcome back. So let's talk about some shading. Now it's very important to mention that I use the ACES workflow, and this is a LUT that I apply in the viewer and in Nuke as well. So the way to do that is by going through the load menu and then specifying this aces.lut file. I'll provide that and you guys can experiment with it. This just allows us to get more interesting colors out of the in terms of highlights and shadows, pretty much. And this workflow is also available in Nuke, and we can easily get the same look without having to do anything complex like it used to be before. So what I did here is I included the main geometry, and this includes pretty much everything that we care about, the main stuff. And I want to talk about this part, the shading for this. But first of all, I want to do two renders. So right now it's rendering using 4 and 8 samples, which is pretty high. And I want to do another one using lower settings and do like a 4K render just to show the details in this section. So wait for it to finish. And you can see there is a highlight, there is a reflection. Let's take a look at the specular direct. You see the specular here. It's not too strong, but there is a reflection of the lights on this wall. Okay, let's take a look. So I'm gonna pin this. I'm gonna lower the settings to 3 and 5. And I don't need global illumination. I'm going to increase the render to 4K. And let's lower the, let's leave it at that. That's fine. And basically I wanted to show this wall. So I'm going to shift drag. And this is going to change the region to only be to only render this, and this is gonna give us a faster preview here at a higher resolution. And I don't have global illumination, as I said, on, but that should illuminate all these areas. And we still have information in the environment light if we wanted to bring this up, and this is a good opportunity to take a look at the environment light colors. So let's see. Should see some buckets. Yeah, it's finishing. And if I zoom in, you can see we have a really nice bump there. There is nice reflection on the edges as well. And I basically wanted to show this shader in details and then talk about how I did the randomization and how I used the inside attribute. How I did the randomization between the brick pieces and how I used the inside face to switch between front and back and outside and inside. And you can see, you can feel the bump here. Okay, so let's take a snapshot of this, and I'm gonna lower the resolution back. So 1 and 1. And let's select all this area. Okay, so let's go to the shader for that section, and I believe it's called concrete. Concrete front level 1. And the easiest way to check is by disconnecting. Yep, so that's the shader. And I'm gonna start going over all of this. Now, I had an issue with the rest attribute being a vector. So what I did, I exported rest.x, rest.y, rest.z as 3 floats, and then this node here, I'm reading the attributes rest X, rest Y, and Z, and exporting that as and converting that float to RGB, so I get a vector. So that's the only thing. And let's plug that in here. And I'm gonna move this node so we can do checking. And I think it's not working. It's working. So I'm using that with a noise function to generate a noise on this wall, and this information is going to stick. This noise is going to stick to the wall because it's based off of the rest attribute, which doesn't change over time. Okay, let's take a look. The other thing I did is I used the X and Y position to create a gradient or a ramp. So it's going to start 0, 1, and then 0 and 1 in this direction. So let's take a look at that. This is my SD ramp, and I can use the I made this to basically map texture onto this wall because I didn't create UVs on them in the first place. So I used that with an image that looks like this, which is just a, what's it called? It's a RMPG. I think it's from, yeah, it's from Megascan textures. So I use this one, and let's see, what's this one, and then another variation of concrete, and I used a noise function to mix between both of them. So I used the cell noise that was generated based on the rest attribute as well, so it sticks, and then I used a float to remap the colors to get more variation or sharper variation, and then I use that to mix between these two, so I get nice texturing overlay or more variation basically. Okay, and then what else did I do? And then the attribute, let's hide this, and then the attribute, the inside and outside attribute, let's connect this. So you see it's white on the inside, you can see the cracks here, and I'm using that attribute to switch between two versions. The main diffuse is this, so that's going to be the outside, and then the second version that I'm going to use is this one, this texture. So it's the same, it's just much darker that it looks brown. That's it. That's all there is. And then I'm doing a gradient, a darkening of the bottom based on this. So I made a mask using the height. So this mask, let's go back. So the rest attribute, we have a noise pattern, right? And then I remapped the Y position, and this is the rest Y, so it always sticks. And we're remapping that between 0 and 1. And I'm combining both of them. So I'm using an add function to add a noise to that to the ramp, and then using that, connecting that through a ramp to float to get this mask by just remapping the colors. So if I leave it at that, it's going to give me the same result, and if I reduce it, it's going to be clipped to the bottom. And then I'm using a noise, generating a cell noise pattern like this, and multiplying both of them, so I only get noise at the bottom part, something like that. And then that goes into a color correct node, and that's the effect. So here I'm simply multiplying, this is nothing, and then I'm multiplying the bottom part with this color. Okay, so that's our diffuse. Now the next thing is I'm using the same diffuse color, or the red channel of the diffuse color, which is this one, to drive the specular color, so it's not uniform. And then I'm using the same information to vary the roughness of the specular. So let's do this. Let's connect this, and I'm going to disable the bump for a second. And this is the shader without any roughness, or Yeah, let's disconnect the roughness. So here it's very clear reflection. You can see the edges here. Let's go to specular direct and let's gain it up. And you can see how flat the reflection is. It's a pure mirror right now, and it's reflecting the environment only. And we're using that specular color, so that's why we're getting these variation. And then as I increase the roughness, it's gonna get blurrier and blurrier. So that's the reflection, and it's reflecting the lights as well. And what I did is I used a range node to get more variation. So by remapping that red channel, which is this one, by remapping that black and white between 0.3 and 0.7, so I get a roughness value of 0.3 here where it's dark and 0.7 where it's white, and that's gonna just add more layering to the visual. And then I'm gonna connect that into the roughness back again, and now we have a variation in the roughness. Now the bump is using the same information, and I'm connecting that to the normal, and the bump amount is 0.01. it's lower at 0.025. You see the higher, the stronger the bump is, and I found that a value of 0.1 works quite well. Maybe a value of 0.5 works quite well for a far away angle, but then as we get closer to the geometry we have to tweak that. But in this case I used one value for all of them. Yeah, maybe something like this as well. Let's go to 0.1. Let's go back to 0.1. I'm gonna cancel this render. I'm gonna go to frame 100 and let's hit render again. And I want to get different geometry exported to show the interior faces. Pardon me. And it's taking a bit of time for it to export because we have SOPs processing. SOPs processing the and unpacking geometry, but if we were reading this directly from Alembic, it would be a lot faster to start rendering the geometry. Okay, so our new geometry. And let's go here, maybe select just a section. And I'm gonna change this color to something completely different so we can see it right away. Yeah, you can see the blue there. So those are the interior faces. And that's pretty much it. That's how it works. Okay, I'm gonna undo this, and I'm going to select this region, and let's go to the out context. And what I want to do is turn on motion blur. And motion blur is currently done using the velocity vector, which is stored in the Alembic file. It may not show up here because it needs to re-export the geometry, but it's gonna work just fine. So when you render with motion blur, you may want to increase the camera samples depending on how close you are. And that's for the motion blur. For the GI, I turned it now. You can see the effect there right away. And the higher the bounces, the slower it's going to be. So I used, for the final render, I used a value of 1 to get global illumination. And that's pretty much it. And the next video, let's do a render. In the next video, I'm going to talk about the variation of the bricks color based on the attribute that we stored in geometry. So we'll continue that in the next video. Thank you guys for watching, and see you in a bit.